Good morning and welcome to Bridging the Gap, Advancing America's Battery Manufacturing and Supply Chain 2. Before we start, please let me explain how we will manage this event. Your video and audio were automatically turned off when you joined. If you have difficulties related to technology, for example, if you can't hear a speaker or see the slide deck or visuals, we recommend you exit the event and re-enter. The public chat and Q&A have been disabled. You will have an opportunity to share feedback at the end of the plenary session during live polling. Closed captions are enabled for this event. If you would like to view the captions, please enable them by clicking Live Transcript in your Zoom settings. Please note that this event is being recorded and may be made available for viewing in the next few weeks. It is now my pleasure to introduce Venkat Srinivasan, the Director of the Argonne Collaborative Center for Energy Storage Science and Deputy Director of the Joint Center for Energy Storage Research. Take it away, Venkat.
Thank you so much, Bethany, and good morning to everybody. And thank you all for attending the LiveBridge workshop specifically focused on non-lithium batteries. We have a lot of people registered for this event, so clearly there is a lot of interest in this topic of non-lithium batteries. As Bethany said, my name is Venkat Srinivasan. I'm a scientist at Argonne National Lab. I'm also the lead coordinator for the LiveBridge Alliance. I will be the MC for this event, walking you through the morning session. A quick reminder that LiveBridge is a public-private partnership that was sponsored by the Department of Energy. The public side of the consortium is represented by FCAP, the Federal Consortium for Advanced Batteries, along with the national labs. The private side is represented by 3 trade associations, NatBat, New York Best, and New Energy Nexus. They represent the private side of the collaboration. You will hear from both the FCAP folks and the LiveBridge folks this morning as part of the plenary session. The goal of LiveBridge is to create an innovation ecosystem to bridge the battery supply chain gap. Now, supply chain is something that everybody is talking about. This wasn't true even, say, 4 or 5 years ago. And the reason is because the market for batteries is booming for transportation, for grid, for defense. Every application, it feels like we're electrifying, and energy storage in some form has become central to that transition. And depending on who you talk to, the estimates of the demand for energy storage in the next 10 years in the US is going to be somewhere north of multiple terawatt hour, right? So there's a lot of batteries that have to be made fairly quickly. We are in the middle of an incredible moment where we're witnessing this transition of this energy infrastructure firsthand, the kind of transition that kind of happens once in a century. And the reality is that this is happening because of the rapid reduction in the cost of lithium batteries over the last decade or so. But this also means that we've become very dependent on lithium batteries, which then brings up the challenge that we have to find a way to secure the supply chain for this very important technology, all the way from minerals to the battery pack. And this is really not just a nice to have. There is a worldwide race to capture the battery market. Every country is trying to electrify rapidly, and everybody believes that the battery of the future is going to be the one that's going to grow their economy. And the US needs to be an integral part of that growing change that is going on in the world, and ultimately be able to do the things that we need to do with this particular technology. What this means is that we have to have a multi-pronged approach that spans both the short term and the long term. The strategy requires us to incentivize domestic production, from mineral refining to cell and pack manufacturing. And we have to think about recycling and stopping the leakage of batteries from the United States. And we cannot forget that we should be working with countries that have access to these raw minerals so that we can get them into the United States. And finally, we should also be thinking about alternates to lithium so that we can see what role they can play in bridging the supply chain gap. So it really comes down to thinking about all of these aspects and not just one single solution that is going to get us to where we need to get to. Now, the reality is lithium will continue to play an outsized role in many markets for many decades to come. But we're also seeing that non-lithium batteries are making a dent, and they've always been around. I mean, many of us use lead-acid batteries to start our cars. But in many stationary applications, we're seeing more non-lithium batteries enter the marketplace. These alternate technologies will be integral as part of a holistic strategy for a secure battery future. In LiveBridge, we've been having conversations about lithium batteries, and we're also starting to think about what are the other forms of batteries that can come so that we can eliminate this critical dependence we have on just lithium. This overall thinking and this holistic perspective is something that we're keeping in mind as we think about the strategy for a secure future. In today's meeting, we will put emphasis on the non-lithium battery part, be it sodium ion or an aqueous battery made of zinc or lead acid or a flow battery component. These technologies, some of them are going to be at a high enough technology readiness level and manufacturing readiness level, and they're prime for domestic production in large-scale manufacturing facilities. What we want to do today is understand the state of the technology, the manufacturing challenges, the supply chain issues, and the role these technologies can play in decarbonizing our economy. Let me very quickly walk you through the agenda. We'll start with two presentations from our DOE colleagues. The first one from Dave Howell, who's in the newly established Manufacturing Energy Supply Chains Office, or the MESC office. This will be followed by Ben Shrager, who's from the Office of Electricity, or OE. We will then hear from Eric Shields from the Office of Undersecretary of Defense, after which we'll hear from Bill Acker, who represents the New York Battery and Energy Storage Consortium, or NY-BEST. We will also, after the plenary speakers, have an interactive session. We'll be using a software called Poll Everywhere. For those of you who joined last year's webinar that Argonne hosted on behalf of LiveBridge, we used the exact same software. It was very useful for us in terms of getting information. This will be an opportunity for all of you to give us feedback on what is it going to take to build a domestic supply chain. This session is a great opportunity for you to give the kinds of input that the federal government is looking for as it starts to look at the future and how to incentivize the movement towards domestic production. We expect the plenary session to end at 12:45 Eastern time today, so approximately an hour and 40 minutes from now. For all of you who are registering through our site, you would have noticed that we were also asking you if you want to have one-on-one sessions. Some of you have signed up for it. Thank you for doing that. So this afternoon, we'll be doing those one-on-one conversations with the federal government and with private companies so that we can dig a little bit deeper into manufacturing challenges for non-lithium batteries. And those are closed-door sessions. So, we want to make sure we have candid conversations there. So with that, let's get the program started today. And I'll start off by introducing the first speaker, Dave Howell. So Dave Howell is the acting director and principal deputy director of the Department of Energy Office of Manufacturing Energy Supply Chains, as I was mentioning. It's MESC for short. Many of you know Dave from his previous incarnation, where he was in the Vehicle Technologies Office. He was there from 2003, shepherding all of the battery R&D for the last 20 years. And all of you who've been in that office, and I actually came to that office in 2002 when I first got a postdoc when I was at Lawrence Berkeley, have seen that program grow and really shepherd the R&D in this country. So Dave has watched this very carefully over the last 20 years and now is in charge of thinking about the bipartisan infrastructure law and all the activities that we need to establish a domestic production. With that, let me hand it off to Dave. Dave? Dave, you're on mute. Oops.
Am I good?
Perfect.
Hear me now? Okay. All right. Hi. Hey, thanks everyone for joining us today. This is a really important part of our planning process, as you'll see as we go forward in this meeting, in this plenary. As we build out our new office, Manufacturing and Energy Supply Chains, MESC for short. As Venkat said, it's a brand new office in the Department of Energy. I'll have a few slides to sort of bring an introduction to MESC if you're not familiar with it. And it is different than what's normal in the Department of Energy as we work to shore up our energy sector industrial base. Before we take off there, I do want to give some thank yous out, particularly for Argonne National Laboratory and Venkat and his team there. You guys just do a terrific job supporting the Department of Energy and efforts like this. So we really appreciate all that you do. It's certainly not, it can be a heavy lift to pull these things off, and particularly in the time frames in which we need them. And of course, the LiveBridge Alliance, which is broader than lithium, but New York BEST, particularly NatBat and New Energy Nexus, all your support there, and bringing in the non-lithium battery players as well from your associations to participate in this meeting. That's important to us as well. And of course, the MESC team, Stephen Boyd, Julie Francis, Mallory Kleitz, and the team there to help shepherd these types of meetings and continue to support the MESC initiatives as we go forward. And thank you to Ben Shrager, Eric Shields, and Bill Acker for being part of this plenary. So with that, let's launch into my presentation. Again, Manufacturing Energy Supply Chains, a brand new office. I'm the Principal Deputy Director of the office. It's just a little over a year old, and it was born out of the IIJA, the Infrastructure Investment and Jobs Act, and even more recently, the Inflation Reduction Act as well. So even though we're a new office in the Department of Energy, we do have some significant funding and appropriations that we're executing, as you may know. So next slide, Bethany. So for MESC, our mission is, like I said, is different. It's to support scale up and deployment of the manufacturing infrastructure critical to the nation's energy supply base. We call it the ESIB, the Energy Sector Industrial Base, similar to the Defense Industrial Base, obviously focused on the energy sector for the Department of Energy. We do things a little differently than the Department of Defense, since we're not actually the customer. We're not the end user of a lot of the things that we're supporting. It's a commercial activity. So we do engage with key stakeholders in each of the areas that we're focused on, and such as what we're doing today, engaging with key stakeholders in the non-lithium battery sector. But there's three things that we focus on: establishing critical supply chain manufacturing capacity, things where the U.S. is either is short on or is missing from the U.S. domestic manufacturing supply base, or just needs to be supported and stood up. And also leveraging private sector investments as well. We also have activities to reduce industrial base carbon emissions through manufacturing facility upgrades, and of course, increasing clean energy jobs and training energy sector workforce. Said we're a new office, but we inherit a little over $16 billion of BIL, IIJA, and IRA funds that we're executing now. Part of that includes the $6 billion from the IIJA Section 40207, battery manufacturing and processing grants, which is the focus of my presentation and this meeting. So next slide, Bethany. So just to show where we are in the Department of Energy's landscape, in the RD&D landscape. So, typically on the left side, that's what you are familiar with, the basic research activities, the applied research activities that we fund and have funded for a long time in the Department of Energy. The right side is the new portion, which actually bridges the gap between our research and development and small scale demonstrations to literally large scale demonstrations and deployment of technologies. And so three big offices related to our infrastructure work, the Office of Clean Energy Demonstrations, and then the Loan Program Office, which basically supports debt financing, and then the Office of Manufacturing and Energy Supply Chains, MESC, which again, supporting scale up and deployment of manufacturing infrastructure. Next slide. So I mentioned that the focus of this is to continue to build out and go to the next phase of executing the 40207 B and C battery manufacturing and processing grant program, and that was provided to us to manage through the IIJA. But also the IIJA provided specific direction to the program, which we'll continue to adhere to. And I've got basically two slides that you could ruminate and sort of just define our program. And so one is the size of the program. So, 207B is for battery material processing, and 207C is for battery manufacturing and recycling. And you see there's similar language on both sections, and grant programs for battery materials demonstration projects, or battery component manufacturing or recycling projects as well. Those are demonstration programs, large scale, and then also support new commercial scale facilities, whether it's battery material processing or component manufacturing or battery manufacturing or recycling, or to retool, retrofit, or expand existing facilities. And so, and then of course you see on the bottom here, the minimum grant award size, which sort of defines us. So for the demonstration projects, the minimum federal share is $50 million, and that defines the minimum private sector share because it's a 1-for-1 match. So federal government will put up a minimum of $50 million for any one application, and the private sector has to match that by 50 million or more. And so that's for demonstration projects and for the retooling and retrofit and expanding facilities. That's our bottom line. For brand new facilities, it's the minimum play is $100 million federal, which is $100 million private sector match. So you can see these are very large programs, and they're really focused on developing production capacity or manufacturing capacity in key areas of the battery supply chain. Next slide, please. So continued definition, what is an advanced battery? What is an advanced battery component? What is a battery material considered? And we basically, make it easy for you, but you can refer back to the 40207 definitions and IIJA. So you see a battery material is simply defined as raw and processed form of a mineral, metal, or chemical, right? And it's a material used in an advanced battery component. And of course, the battery components are defined for us in number 2 here, which would include things like materials, cathodes, anodes, electrolytes, things of that nature, enhancements, enclosures, and other associated materials. Moving into advanced battery, which means a battery cell, it consists of a battery cell that can be integrated into a module packer system. So those definitions are given to us by the law. And so we do adhere to those definitions. So with that, most of you probably know that we finished out our phase 1 effort in this area. And I will also, I failed to mention that in 40207B in the Battery Materials and Processing Grant Program, IIJA provided a total of $3 billion for that. And then in 40207C, the Battery Manufacturing and Recycling Program, there was another $3 billion appropriated for that. So in phase 1 effort that was closed out in October, next slide, please, Bethany. We selected 21 projects, and we spent, a little over 2.8 billion of the 6 billion total. But the recipient share, you can see there was significantly more than that, $6.2 billion. So private sector really stood up and to make this play. So those 21 projects, cut across a large swath of the battery supply chain. From cathode materials like lithium hydroxide, nickel sulfate, to cathodes and anodes, both cathodes, iron phosphate, and the layered structure, nickel manganese, cobalt, nickel manganese, aluminum type. The anodes, both graphite, natural graphite, synthetic graphite, and silicon, to precursors, separators, to processing and recycling. And all those really are focused on the lithium-ion battery space. And just the next slide, some major highlights coming from those selections. As I mentioned, developing enough battery-grade lithium hydroxide to supply 2 million EVs annually. Battery-grade graphite, both synthetic and natural graphite combined, to 1.2 million EVs annually. Battery-grade nickel, 400,000 EVs annually. The first commercial-scale domestic silicon oxide production facilities. A rough estimate is 600 million EVs annually. And then, of course, the first lithium iron phosphate cathode facility in the US, and establishing the first large-scale commercial lithium electrolyte salt production facility in the US. So, and then the next slide, some continued highlights of, this is the first time that we had the community benefits plan as part of the application process and part of the evaluation and selection process. So we got some good results there from the community benefits plan. So These are some highlights of things to consider as we go forward. Some of the applications in disadvantaged communities, we had 5 particularly, and then DAC adjacent was 16. So that's significant play right there. A lot of jobs reporting. Still working on finalizing some of these numbers, but total reported construction and permanent jobs of over 8,000, 5,000 permanent jobs. And then a lot of different unions were part of the applications that were selected. And of course, a lot of connection with MSI and HBCU institutions, as you see there. Then on the right side, some notable things that were part of the application process. I put this up there just to give you ideas as we go forward on how to respond to the community benefits plans and the types of things that can be imported. Certainly not a comprehensive list, and you certainly don't need to do all of these things on the list, but things that are specific to your area, that if you're looking to put in an application for our program, our phase 2 program, then these are some of the things that you can consider as good responses to the community benefits plan, or any other innovative ideas and thoughts that you might have as well. So let me finish with one more slide. And this is our path forward. So I talked a lot about phase 1 and what we did. And so there's a phase 2. We've only actually committed $2.8 billion to those selections. They're all undergoing negotiation for award. So we continue to have, of the 2 provisions, $3.2 billion to spend going forward. So in phase 2, we are starting to build out the next funding opportunity. And so here's some key things that we're considering. So the first phase, certainly supported the high capacity battery supply chain. A lot of the things that came right out of the president's 100-day supply chain report that was published in June of 2021. We supported a lot of those activities with the BIL funds or the IIJA funds. And but in this next phase, we do want to consider ways to provide opportunities for projects that focus on non-lithium battery chemistries as well. And that's what this day is all about, this discussion is all about. And so some key things, not only the focus areas, but the markets and the commercialization thoughts here. So lithium-based batteries, are commonly used for on-road light-duty transportation, certainly the main player there. But there are other potential markets to include, which would include medium-duty and heavy-duty, as you see here. Both on-road and off-road are applicable. Marine and rail systems, stationary storage systems, and defense and aerospace applications. So as you think through whether you have a play here with the next opportunity, there are some areas in the domestic supply chain that we do want to support, as you see here. Some other things on the right side here, important aspects of the evaluation and selection process. I mentioned that this is different. This is literally not about research and development. It is about installing manufacturing capacity and leveraging and supporting private sector investment to do so. And so these 4 things are really, really important. Proposed technology that's technically viable for the targeted end-use application. So, be considering how you would show that in your application and how impactful that your application would be to the domestic battery ecosystem. And then separately, the commercial viability is really important of what you actually propose. What is the market adoption expectations, current and future? And what is your customer demand? What are your customers telling us? And having your customer as a partner could be really, really important too. And of course, the applicant and team's capability to successfully complete the project. And that's both successfully financially complete the project. These are large private sector cost shares. So understood, that's a big issue. We don't want to get halfway through a project and, let's face it, the applicant run out of money and private sector money. And of course, operationally complete the project, that you have the team in place that can provide the confidence that you can start the project and operationally complete it, and at the end have a functioning production capability. And I'll mention the community benefits and impact. That's going to be important as well as we go forward. So with that, I'll stop and turn it back over to Venkat. I will say that we are open. Our team at MESC is open to discussing these things with you as we build out this over the next few months. So if you have some interest in following up with us, feel free to do so. So Venkat.
Dave, thank you so much. I appreciate it. Actually, it's exciting to see all the things that have already happened in the first tranche of the BIL funding. And it's great to hear there's a second tranche coming, including the global picture of thinking about not just the technology, but also about the community plan. So that's really fantastic. I just wanted to sort of quickly reflect on this, right? So I've been in the battery space for 27 years, 20 of them in the DOE system. And frankly, many of those technologies that were nurtured in sort of the scientific areas have matured to the point where today, these offices are able to provide this kind of large funding. And I think we've seen these stories across the board about things that were at a very early stage. When I actually started, it was lithium iron phosphate. It was such a bad material, nobody thought it would be useful, but here we are today. And as we go to the next speaker, I wanted to comment that DOE actually has an amazing portfolio of R&D across the different offices. The Office of Science runs the Energy Innovation Hubs. Bethany mentioned J. Caesar, which I'm part of, and that's one of the Energy Innovation Hubs, but they also have the Energy Frontier Research Centers, many of them looking at next generation, beyond lithium-ion chemistries that can be the sort of the feeding the pipeline. You heard about the Vehicle Technologies Office, which has been nurturing this kind of R&D for many decades now, kind of moving it up the higher TRL. And the Office of Electricity, which we'll be hearing from Ben in just a second, has been thinking about this for a long time for the stationary storage. And one of the areas which has become very important for us is long duration storage, which really is an important topic as we think about what kind of chemistries and technologies are going to power that very important as we get to high renewable energy where long duration becomes important. Ben is with the Office of Electricity. He's a storage strategy engineer with that office in the energy storage division, where he leads projects to analyze, develop, and inform the strategy for energy storage R&D across DOE and OE. And Ben is currently leading what is called the Storage Innovations 2030 initiative, an effort aimed at developing OE's long-duration storage strategy to enable innovation and maximizing energy storage adoption in the US. So let's hear a little bit from Ben in terms of what they're thinking when it comes to the areas of energy storage. So Ben, take it away.
Venkat, thank you so much. Really couldn't have framed that better. It was a really perfect segue into what I'm going to be talking about for a couple minutes today. Just want to thank everyone for coming out this morning and today for this really exciting event. Appreciate the opportunity to speak and share a little bit about what OE is doing in this space. So I'm going to provide some context first of sort of how we're thinking about long duration storage and share a little bit about some of our ongoing activities, similar to what Dave just talked about. So let's just go right ahead onto the next slide. I want to again share how we're thinking about storage and long duration storage as an enabler for grid decarbonization. We sort of think about it in terms of where we are today and where we're going into the future. So this is really meant to be illustrative. I don't have all the specific numbers offhand, but this graph sort of shows where we were as of 2020 with regards to grid scale energy storage deployed in the US. So really the largest slice of grid scale storage came from pump storage hydropower, pretty big chunk, several gigawatts there. And then we also had some batteries that were deployed on the grid scale. Most of the pump storage dates back decades, whereas a lot of the newer deployments are lithium-ion batteries in the grid. And if you click ahead one more time, you can see where we're going into 2030. If we have under business as usual projections, how many battery or what capacity of batteries we're deploying, as well as if every single project in the pump storage development pipeline was fully built out, what capacity we'd have there. And if we click ahead again, we can see that as we head into 2035 in a 100% clean electricity scenario, even in the low case, there is a significant gap between what our business as usual projections are for grid scale deployment and for where we need to be. And so we have and if we click on one final time, we can see that into 2050, the need for even longer storage is clear. We no longer just need storage up to 10 or 12 hours. We're really looking at weekly and seasonal duration energy storage that can supply power over entire weeks or seasons during general lower times of power supply. And so as we think about where we are right now, and where we really need to be quite soon, just over the next couple of years, the need to explore all of our different technology options should be clear. And we think about lithium-ion batteries as the most currently deployed technology on the grid for new deployments. So in 2021, 2022, the most deployed new technology for grid storage was lithium-ion batteries. But those are expensive for long durations for 10 plus hours. And of course, there are supply chain considerations and competition from the transportation sector. So there's really this need to look beyond lithium-ion. And of course, pumped storage hydropower is a proven technology that we've used for decades. But there's really an insufficient number of sites for the traditional PSH solution that we've deployed. And these are very large, expensive infrastructure projects that take a very long time to deploy. So we really need new technologies that have lower duration costs and fewer siting limits. That's really our great need right now. So let's go on to the next slide. This is where a lot of the context for why we launched the long duration storage shots. This was this is currently our guiding strategy to significantly reduce the cost of long duration, 10 plus hours, long duration energy storage. So we're looking to reduce storage costs by 90%. That gets to a 5 cents levelized cost of storage, 5 cents per kilowatt hour for long duration storage by the end of this decade. This is an aggressive target, and this looks at any kind of technology solution that could potentially meet this goal. And so on to the next slide. This just shows sort of why 5 cents, why this target. The idea is that with this levelized cost, with this very low levelized cost of storage, we could see that renewables plus storage becomes competitive with existing electricity sources. So this is really about significantly lowering the cost for the use case of grid decarbonization and really enabling high penetration of renewables. So let's go on to the next slide. Here's another look of where we are today in terms of different technologies. I think some of this might have gotten a little cut off, but each of these lines here on the left graph show a different technology. So that dark blue is compressor energy storage, the orange is pumped storage hydropower. We have a couple different lithium-ion chemistries on there. Again, a couple got cut off from the key, but essentially we're looking at the different costs for different energy storage technologies. And this comes from the Pacific Northwest National Lab's cost and performance report that examines these different technologies and has some sort of business as usual learning curve type projections that project out to 2030 what the anticipated levelized cost of storage will be. And in a business as usual case, in their projections, no technology meets the aggressive 5 cents long duration storage shot target. And so what does that mean? It means that there is this gap between the costs of these technologies in the future and that target. And we really view this not as an insurmountable challenge, of course, but as this RD&D gap, a gap that can be addressed with further research, development, and demonstration. So by enabling some of these new technologies, we are hoping to significantly reduce the cost, both by examining technologies that we already know about, as well as trying to unearth new and innovative ideas that could potentially meet this target. And so for grid storage, we're really looking at the whole range, anything that can store energy for a long time, cost effectively. And so, this is really a lot of our context for how we're thinking about long duration storage costs on the grid decarbonization use case. So let's go to the next slide. In the Office of Electricity, I just wanted to highlight a couple of the programs that we have in our office related to energy storage. So we are looking to address a lot of these issues. And I just mentioned a lot about technology developments. That really comes from that first box there, one of these pillars of the OE energy storage program that looks at cost competitive technologies. So we're researching a number of different technologies, materials, systems, power electronics that can lower the cost of storage and increase performance in the next several years. There are a couple examples listed there. Those are just a couple. There are many, many technologies that we look at and that we're interested in, and we're always interested to hear about the next greatest technology. A couple other areas of note, we are very interested in safety, right? So not only keeping the systems cost effective and high performance, but also safe, right? And so there are obviously safety issues that have come across in the news with regards to lithium-ion batteries. And so keeping those systems safer, deploying new and safer lithium batteries, and also exploring new technologies and new chemistries that are safer more broadly. And then there are some other areas as well related to regulatory issues, quantifying the benefits to industry, and leveraging field demonstrations. And so when we get to the field demonstration markets piece, that's really where OE's portfolio starts to end, but other offices at DOE will take over and really bring the next generation of storage to market. Let's go to the next slide. We've also launched the Energy Storage Grand Challenge. I'm sure probably most of you on this call are familiar with the ESGC in some capacity, but this launched in 2020 and is the effort to really coordinate energy storage efforts across the Department of Energy. So I've talked a lot about grid decarbonization just now, but of course there are a number of other use cases that energy storage can provide. And this is not necessarily an exhaustive and all-inclusive slide here, but of course, electrified mobility is key. We were talking about that earlier, thinking about critical services or remote communities and the role that storage can play there. Interdependent network infrastructure, facility flexibility. There are a lot of exciting use cases, and each one of these could be its own several hours long presentation. So I won't delve into too many more details. But this is a really exciting way that we're thinking about storage. And this is how we're really bringing together all the different offices within the Department of Energy to tackle these specific challenges within storage. Let's go on to the next slide. I don't want to go over my time too much here. Just as one of the final things I want to bring up, and I talked a lot about this earlier, but this is really a listing of some of the specific technologies that DOE has supported. This is a pretty inclusive list that covers a lot. And over the last several decades, DOE has supported dozens of different storage technologies. But as we think about the long duration storage shot and where we're going into the future, if we click ahead one more time, we can really see the need here. The need is really around a strategy. And if we continue to support every single technology as much as we can, we're not going to be able to have the clarity needed to develop, scale, and deploy which of these technologies are most promising to meet the long duration storage shot. So we're really trying to perform analysis now to best target our investments. And that's why we launched Storage Innovations 2030. It's described on the next slide. And click ahead one more time. Actually two more times. Let's get the whole slide showing. Thanks. So this is our effort to craft DOE's long duration storage strategy. We have three main pillars here. I'll talk about each one briefly, but if you click on that, or go to the QR code in the top right corner, you can go see more on our website on storage innovations. So this is an ongoing effort right now. We're currently working on these three pieces of analysis, and they will be released in public reports hopefully within a couple months. So we're hard at work right now on this analysis, delving in for these different technologies. The exception actually is the prize. So the prize competition is closed. I'll go into that in a second. So let's go on to the next slide. I'll just briefly describe each storage innovations effort. This is, the first one is the framework. This is an industry-focused framework to quantify the impact of different RD&D activities on future cost targets. So we're really taking a close look at different storage technologies and all of the different areas of potential innovation. For example, for lead batteries, we've identified those areas of innovation as some of the most important to focus on, or some of the broad categories of innovation that have potential. And we've done some analysis on which might be the highest impact. Obviously, we're not claiming to predict the future, but this is a really interesting effort that's looking at some of the directionality of these RD&D efforts. So I just included a couple example figures there, but we'll be releasing the thorough analysis again within a couple months. The next part of Storage Innovations on the next slide is the prize. So we ran a prize competition. This was really aimed at exploring early stage, next generation innovations for grid scale storage. So we really wanted to focus in on the technologies that we might have missed as part of the framework of the flight paths efforts. And so this was a $300,000 cash prize where we had 10 winners total. And we saw winners across the board, from thermal storage to mechanical storage to chemical storage and more. We really saw an interesting mix of winners. And I just want to highlight our winners. If any winners are on the call today, congrats. But this was a really exciting way to highlight some of this innovation. And the final piece of Storage Innovations, and then I'll go on to the next speaker, on the next slide, is the flight paths. And so we've been holding flight paths listening sessions over the last couple months. These have been technology-specific sessions that have brought together the industries of different storage technologies. You can see our schedule there on the right. The goal has really been around examining pre-competitive R&D opportunities and the areas of consensus where industry can collaborate to drive forward a common technology goal. So these have been some really interesting discussions. We've had some great participation hearing about these different technologies. I want to note, if anyone here is interested in contributing and then having a conversation about the future of storage or pre-competitive R&D, and if you missed your specific technology session, or even if you didn't, and I want to continue to contribute, we actually have our final listening session this Thursday at 1 p.m. Eastern. And you can register to attend right on that link. It's right on the QR code. It's all free, and it's just a great way to engage. So would encourage anyone who's interested to come out. Thank you all so much. That's all that I have. I really appreciate the opportunity. Thanks a lot.
Thank you so much, Ben. I appreciate it. There were two things that stood out. One was I loved that wheel diagram that had the many different technologies that you guys were considering. So, I mean, clearly, when you think about the long duration storage shot, which is the second thing that stood out, those aggressive targets for the Earth shot, you kind of have to think about every chemistry that is out there and every technology that is out there and find out which of those could make the most sense. So you can all see that there is a comprehensive view. And as I was mentioning in my previous comments, right, there's this incredible, sort of connection in the different parts of the Department of Energy doing different things, but all working together towards that broader outcome that we need to push towards technologies that can be commercialized with the US so that we can get a secure supply chain. But it turns out that collaboration is not just within DOE. I briefly mentioned in my comments in the beginning the Federal Consortium for Advanced Batteries. This is a group of 14 plus federal agencies that have come together so that they can have a strategy and sort of implementation plans towards this vision that we'll have a secure domestic supply chain. As part of that, the Department of Defense is an integral member there. And our next speaker, Eric Shields, is going to talk a little bit about that. Eric is a senior battery advisor in the Industrial Base Policy Office in the Office of Secretary of Defense and is responsible for addressing battery challenges in the defense industrial base. He was formerly held the position of the Department of Navy's Deputy Director for Operational Energy and as a branch manager at the Naval Surface Warfare Center, Carderock, leading operational energy and lithium battery safety efforts in the Navy and the Marine Corps. With that, Eric, take it away.
Thank you, Venkat. Just a quick test of the mic.
We can hear you.
Okay, excellent. Well, apologies for no video today, but we will jump in and get started. Today, I'm hoping to kind of walk through some recent activities in the Defense Department and provide perspective on where non-lithium batteries and non-lithium chemistries might play a role in supporting defense needs. So appreciate the opportunity to share with this audience kind of where we're coming from. So we'll move on to the first slide. So in my office, we focus a lot on supply chain security, and obviously in this case, focused on security for the battery supply chain and in the defense industrial base. And kind of if you're looking at public documents that provide a framework for where we're coming from and how we see these challenges, We can start with Executive Order 14017. What came out of that executive order was a joint product, an interagency product, which was the 100-day report. And I imagine folks on the phone have read this report and the one-year versions that came out of that as well. So Department of Energy from that joint report published their outcome, their one-year report, as did DoD. So within that report were a number of sectors that Defense identified as critical focus areas and areas where we were going to provide recommendations on how to improve supply chain security for those sectors. And of course, batteries was one of those. So next slide. Coming out of that, that report, one of the recommendations in the battery sector was that the Defense Department needed to put together a battery strategy to connect all of the ongoing efforts within the department together in a cohesive form. That report, or that strategy rather, was published in February. It is not a public document. However, we are in the process of publishing a public landing page that will have an FAQ section and a little information about the strategy for folks who are interested in it. So I expect within the next 2 weeks that'll publish. And if you have an interest in that, we will get the link out as soon as we can. So just reach out to me separately and I can provide that. Within the strategy, although it's titled the DoD lithium battery strategy, it's actually chemistry agnostic. So we focus on lithium because a lot of the technologies that we are fielding to support our applications at this time are increasingly lithium ion. So there's a transition from legacy chemistries like NiCad, like lead acid, to lithium ion technology in a number of areas. But there's nothing about this strategy that is focused on a particular chemistry. We, as folks who work with the Defense Department, while our demand is not particularly large in the context of the commercial market, we have very diverse requirements because we operate in a wide range of environments. And that means that kind of any chemistry that offers any advantage in one of these areas or is particularly dominant will typically find a home within the Defense Department to meet a particular need. And that's certainly true in the operational energy world. So any of our operational systems have very diverse requirements. It's also true in the grid domain, right? Our installations, making sure that we have energy storage to support those. And in that arena, our requirements are very similar to those that were just reviewed in terms of installation, energy storage, and ESS. So next slide. If you have not read and you're interested in DoD requirements, pulling up the public national defense strategy is worth your time. One of the things that will become apparent within that strategy is that we are increasingly focused on the defense industrial base, fortifying it, strengthening it, working with our international allies and partners together on that. So the industrial base is a common theme within our national defense strategy. And what you'll also see is a number of applications within that document that are all supported in some way, shape, or form by battery technologies. So I put down, currently both primary, secondary, reserve type applications that we see today. And I put down a couple of examples of where we might see other chemistries pop up and play a role in supporting the department's needs. But as I've pointed out, really the best and most effective chemistry in meeting our requirements is going to be the one that a program office or a given service is going to procure and field, because they are focused above all on mission. And so chemistry is not something that drives our acquisition decisions. It's all about performance. Next slide. So one of the questions we get asked often is, well, this transition is happening to lithium ion, so these legacy chemistries are going to be phased out. Well, in large part, and I think folks who work with the Defense Department, I think they recognize that that's not going to take that's not going to be overnight. It's going to take decades. So we anticipate that for legacy chemistries, we'll continue to use them. And so if you're bringing to the table advancements, even in legacy chemistries, we're interested in that as well. And here's just a couple of examples of where those chemistries play a pretty large role in terms of defense procurement and the applications for those legacy chemistries, whether it's aviation, whether it's an SLI application for a tactical vehicle or a uninterrupted power supply, or whether it's for an undersea application. We use kind of legacy technologies for quite a bit and will for quite a while. Next slide, please. So one of the ways we're thinking about the future, next 5, 10, 20 years, is increasingly a focus on standardization of form factors. So highlighting here that both within the National Blueprint for Lithium Batteries and within our strategic documents that we've published recently, this focus on standardization comes up again and again because we want to create battery packs and form factors that are adaptable. So as new chemistries come online, they can seamlessly integrate into those form factors and go straight into a weapon system or application without having to retrofit that existing platform for that advanced technology that was developed. So we've recently put out a couple of solicitations in this space. I expect that sort of thing will continue for quite a while as we continue to identify multiple source suppliers for the batteries we field and to improve our ability to field common format and standardized battery systems. Next slide. So the landscape, which is laid out in our published documents, in our strategic documents, over the next 5 years will be increased and continued interagency coordination with the Department of Energy and other agencies, working together to just accelerate our internal processes for safety certifying lithium batteries and fielding them and other chemistries, making continued investments, continuing to coordinate with industry like we're doing here today. And as I mentioned, adoption of common format batteries by programs of record. So that's just kind of a sample of what we're working on in DoD. And I think I've got one more slide. So as I've mentioned, we've been using legacy non-lithium chemistries for a long time, and that's not going to change in the near future. But we expect a transition to lithium ion and next generation chemistries is going to be occurring over the next decade or so. As I've tried to emphasize, our requirements drive all of our procurements. So if you have a next generation chemistry that we've not tested, that we're not tracking, and you think has advantages in a particular dimension, don't hesitate to reach out. We are always open to new ideas and new technologies and getting them into our weapon systems. And I think I've kind of harped on standardization, but we view it as a central road through which new technology will be integrated. So we can again develop the form, fit, and function of a battery system supporting an application, and then insert new cells, new chemistries over time to support our needs. So I think with that, I will pass it back to Venkat. Thank you.
Eric, thank you so much. I think you sort of spoke beautifully to this point that different parts of the federal government are sort of talking to each other to see how they can leverage each other's resources to make some things go faster and kind of get up the TRL spectrum. I think many people have pointed this out, and actually this was part of the conversation in the Liebridge conversation that you'll hear about next from Bill Acker, the idea that the defense segment and the procurement there could be a way for us to increase the TRL of the technologies that we have, but also find a way to get to a market which is a little bit easier to get to before we get to the vehicle market and the grid market that have incredibly difficult constraints, as we've heard from the other speakers. So thank you for that. That was very useful. Next, we're going to go to the kind of the other side of this picture. We've been hearing from the federal government, but it takes a village for us to be successful, and that means people like me and others in the academic side and the national lab side of things. It involves a federal government that really has the kind of the strategy that it's been pushing for a long time, and it involves the private sector. And this is where the LiveBridge Consortium comes in, this idea that let's move the public and the private together to get us to where we need to be. And one of the people that I've been interacting with closely over the last couple of years as part of LiveBridge and is Bill, who along with the folks at NatBat and New Energy Nexus and the other folks that are coming out of NY-Best have been doing an incredible job of sort of helping us think through how are we going to do this by bringing companies together. Bill is a well-known and highly regarded scientist, business leader, and entrepreneur in the field of energy. He currently serves as the first executive director of NY-Best. Under his leadership, NY-Best has grown its membership to more than 175 companies. It's created the best test and commercialization center and new battery prototyping capabilities, and has performed pioneering work in advanced markets, policy, technology, and product development. With that, Bill?
Thanks, Venkat. Delighted to be here. Thank you all for attending today, and thank you to the DOE for organizing and driving this event. As Venkat indicated, New York Best is an industry trade association. We do a lot of work in the areas of growing markets, policy, regulatory work, a lot of work in growing the ecosystem, the supply chains, and putting in place the resources needed and connecting companies and having the industry grow. Our real core mission is to grow this sector of the industry. What I'll be talking to you about today is twofold. First is LiveBridge, as Venkat indicated. And then secondly, I'll be expanding a little bit on Ben's remarks on a particular application for non-lithium batteries, which is in the energy storage space on the grid. So we can go to the next slide, please. So LiveBridge, as Venkat indicated, is a public-private partnership. It was created and really did a lot of work last year under the auspices of three industry trade groups, NatBat and New Energy Nexus and New York Best, with the partnership with DOE and managed by Argonne National Lab, and Kat did a superb job leading those efforts. We were fortunate to be able to bring on board Boston Consulting Group that facilitated a lot of the effort. And I think it's important to recognize here that we're going to be talking in the next two slides about the lithium supply chain. But the reason why I think that's important to bring forward is twofold. First, many of the findings that came out of the LiveBridge effort that I'll be touching on are really applicable across the battery industry, including some of the workforce development efforts and some of the siting and permitting efforts, and a lot of the other findings that came out of this report. And second, as Dave mentioned earlier, this model could be expanded and extended to some of the non-lithium sectors. And this meeting, in my eyes, is a really important first step in collecting that information and being able to move that forward. So what we did last year with the LiveBridge group was we convened many industry leaders. Over 40 companies participated, over 10,000 hours of company executive time in the form of 4 key forums and many working groups that looked at what are the barriers associated with building a robust domestic supply chain for lithium-ion batteries. And then went through a succession of efforts to identify what the pathways would be to overcome those barriers and create a set of actionable recommendations that we believe can result in dramatically increasing the growth rate from the business as usual cases. And that was all released in a report and action plan that was released in February. That's entitled Building a Robust and Resilient U.S. Lithium Battery Supply Chain. And I'll just, in one slide, go over some of the key recommendations associated with that, and then get into some of the areas of some use cases on the grid for non-lithium batteries. So if you go to the next slide, please. The LiveBridge recommendations actually have 26 specific recommendations, and we've organized them into 5 broad categories or objectives. And the first objective is improving the investment attractiveness. And clearly, we need to have private capital come into this market in a very major way. And we need to create the right environment for that private capital to support the incredible growth in manufacturing facilities that we're going to need to see domestically. So that first objective has underlying action plans, primarily associated with incentivizing the CapEx, the R&D, the production and the demand, but also government procurement and other ideas that we believe will be useful, like insurance pools and the like. The second objective is to support research and enable product and business model innovation. And this really gets at really leapfrogging within the lithium-ion field, not just trying to replicate what is happening in China, but improving both the processes and the products over that. And there are a number of important recommendations that underlie that. Some of these include having pre-commercial pilot scale manufacturing facilities that overcome some of the key challenges that companies have in ramping up production, including other areas such as R&D investments and commercialization support. The third is to help companies secure access to the critical materials and also low carbon infrastructure. And there very important recommendations around permitting reform and other recommendations such as buying consortiums and particularly circularity, properly using the recycled materials and closing the loop on those. The fourth is a key gap for all areas of the energy storage industry, which is workforce. There are a set of recommendations around curricular development and around training support going forward. And the fifth is to move this private partnership forward to continue to be able to act upon these recommendations. So I encourage you to look at that report that was referenced on the last slide that you can find on the Argonne website and on our website as well. With that said, I'd like to move over now to talk a little bit about energy storage on the grid, because this is a very important use case for non-lithium energy storage systems. And energy storage on the grid, some of this slide is quite straightforward. Clearly, I think everyone's aware the intermittency of renewable generation is driving a need for balancing resources and resources that shift energy. People may be less aware of the limitations of incorporating renewable resources onto the electricity grid. There are substantial challenges with being able to incorporate the amount of resources that we're going to need on the grid. And put very simply, this is in part because these resources are so intermittent that you really need 2 to 3 times the capacity of the renewables compared to fixed resources that are constantly outputting. And that means that you have the risk of dramatically having to overbuild the grid if you don't do things differently. And we'll talk a little bit about that. And the third is large new loads, the incredible load growth that we're going to see around the electrification of the rest of the economy. So we go to the next slide. In New York State, we are fortunate that we have a law passed in 2019 that requires 70% renewable energy by 2030 and a completely carbon-free grid by law by 2040, and also substantial greenhouse gas reduction across the rest of the economy. That's led us to need to really do a deep dive in understanding how you can really have a cost-effective, functioning, reliable electricity grid under those conditions. And that's led to a lot of modeling, and I'll take you through a little bit of that now to go over some of the learnings from there. So if we go to the next slide. The first I want to touch on is the load growth, because when you decarbonize the grid and move to electrified heating, and move to electrified transportation, you see substantial load growth on the electricity grid. So this blue line on the bottom is the 2020 load for New York State annual, over the course of the year, I mean. And then the gray line is a projection for 2040. And you see a couple things. One, it grows substantially, it basically almost doubles. in the summertime. The wintertime goes up by even more than that. We go from a summer peaking grid to a winter peaking grid. And this is highly due to the electrified heating and building loads. And also the variability within the days increases dramatically. And that's driven by the changing in loads that we're seeing on the grid. All of those things are things that are driving the needs for different resource mixes to achieve reliability. So if we move to the next slide, this is from a study commissioned by the New York Public Service Commission, published in 2021, that looked at the resource mix that would be necessary for 2030 and 2040 to achieve the targets. And what you're seeing here is a need for about 15 gigawatts of battery energy storage. That's intraday storage, so hourly storage, nominally 4 to 8 hour storage. And there are lots of use cases that underlie that, from capacity needs, energy shifting or energy arbitrage, to all of the ancillary service products that are needed to stabilize and balance the grid, be that energy reserves, frequency response, and other balancing services. Frequency regulation is something that's a very quick response, and energy reserves are a slower response. The important thing also to note on this graph is the salmon-colored bars down at the bottom. They're labeled thermal because that's what they are now, but they're switching. By 2040, they need to be completely emission-free in New York, and that's going to be replaced by long-duration and clean dispatchable technology. So that's another over 15 gigawatts just in our state alone that's going to be needed. And so the research here has done a pretty deep dive on looking at what sort of needs there are for some of the longer timeframes that Ben was talking about. And the state commissioned an integration analysis that was done by E3 to look at the full mix of electrified transportation, electrified buildings, and the grid, and look at where there are gaps and needs for long duration storage and other forms of storage. So if we go to the next slide, this is are some of the results from that work. And here I'm going to show you 2 different weeks of the year. This is a good week. This is a spring week. And what you're looking at here in the lower graph shows you the week, the timing of the year, and the upper graph shows you the details of that week, where you're looking at the resource generation mix and the load. The generation mix, yellow is solar, blue is wind, the tan are other more fixed assets. And the purple are its energy storage discharge. The red you're looking at here is excess renewable generation. And so you can see this week is handled very nicely by the mixture of renewables and intraday storage. If you go to the next slide, however, you see this is a bad week. This is the middle of winter. And this is a snapshot. These are all done as sampling Monte Carlo style analyses. So this is a bad case example of that analysis. And what you see here is that you have substantial shortfalls of renewable generation, and you need some zero carbon firm resources over about a 6-day period in that week. Now, so one way to do that is to have very long duration or infinite duration clean peaking plants, but the other ways are different forms of storage. And I'll just quickly show you one example. So if we go to the next slide, this is the same week where 100-hour storage was modeled in addition to the 4-hour storage. And that was put in along with some additional renewables. And that handles the scenario quite well, with a small uplift in the renewable generation needed to do that. So the punchline here is that we are going to need a range of distributed assets to cover this, and both shorter duration and longer duration. If you move to the next slide. I mentioned earlier the challenges with interconnecting renewable energy to the grid. And this graph is indicating the growth in interconnection capacity need compared to load. So what you're looking at here is the interconnection capacity need by the modeling in New York, starting in 2020 and going to 2050. And you see we grow from an interconnection capacity need of just over 40,000 megawatts or 40 gigawatts to about 150 gigawatts. Whereas the load is only growing from about 30,000 or 30 gigawatts to about 50 gigawatts. So we're going to dramatically have to increase our interconnection capacity. And the reason why I'm bringing that up is that if we do that purely with wires, we will overbuild the grid immensely. But if we do it with what's frequently referred to as SATA, storage as a transmission asset, in addition to wires, we have a real opportunity to optimize this and make it much, much more cost effective. So if I can take you to the next slide, I just have 2 more quick slides before closing here. So 2 examples of what SATA can do. The first is in dealing with load pockets or generation pockets. So this is an example from Long Island, where you're looking at a deficiency in the ability to transmit power to a load pocket over about a 10-hour period. There's about a 2,000 megawatt hour deficiency, but you have headroom over 5,000 megawatt hours during the other 14 hours of the day. Clearly, energy shifting storage can address that need without having to run new wires. But we need to have the right market rules in place and the technology in place to do that. And I'll close with another example of SATA, if we go to the next slide, which is that you don't necessarily have to have long duration storage to do SATA. The grid always reserves capacity for reliability reasons. So most power lines are not run anywhere near capacity. If you have multiple lines running in a region, you generally are reserving capacity on the second line because if the first line goes out, you need to be able to switch. Or if you lose assets, you need to be able to switch. And so there's always a limitation on the reserves there that can be addressed by simply having energy storage available to pick up that contingency event. This sounds like it actually is free money in a sense, because the battery would just literally be sitting there as an insurance policy in reserve. But it frees up substantial generating capacity or transmission capacity, I'm sorry. This is now being done in Germany. It's being looked at in a few other places, and it's a real opportunity for energy storage on the grid. So I'll close with those points. I want to thank the DOE for helping to create and leading the LiBridge efforts. I do believe that there is a very important role for non-lithium chemistries, particularly on the electricity grid. And we look forward to working with you to grow that supply chain. And I'll mention if you have interest in these topics, there's a conference coming up on to show it on this slide here. And I'll turn it back over to you now, Venkat. Thank you.
Thank you so much, Bill. I appreciate it. 2 things that quickly came to my mind is, we could see how important long duration can be, and a great topic where I think non-lithium batteries can play a big role. So that's something that quickly comes to my mind. The second one is, I think all of you know this, New York has always led this idea that you have to think about what are we going to do on the grid. And there are a few different states like that, not to kind of single out one of them, but certainly New York has been in the forefront on that topic. And for those of you who are interested in the LiBridge report and the recommendations that Bill mentioned, just do a Google search for LiBridge. It should pick it up. At least my browser picks it up in the first one. If you don't, search a little bit more, maybe use words like Argonne, and you will see a site that Argonne hosts that will essentially get you to the report itself. Now we're going to go to the next part of the session, which is going to be an interactive session where we want to hear from you. We want to understand what you think are the biggest challenges that we're facing in the country, that the kinds of things we ought to be doing to get us to a stage where we have a secure supply chain. This is a very important part of the event. So we're hoping that all of you are online to participate. What I want you to do is look at this website here, polev.com/Argonne events. Please use a web browser to log into that particular site. So if you have a computer, it's pretty straightforward. Open a browser, type in this thing, and I'm going to give it a maybe 30 seconds to a minute so that you have a chance to kind of log into this particular site and essentially type what is on the screen, polev.com/Argonne events. Now, if you have a cell phone, you can also open a browser and essentially get to that exact same site. I see a few people that are online. If you don't have a browser on your phone, I think you should get a phone that has a browser, but I mean, that is your choice. I guess if you have one of those old flip phones, you can text us at 22333 with the message Argonne events. So ARGONNE-EVENTS. That should get you access to the particular polling that we'll be doing. But I strongly recommend that you use the web browser to log into the polev.com Argonne event site. So let's give it maybe 10 seconds to make sure that everybody logs into this particular site so that we can ensure that everybody's online. What we're going to do now is ask you a series of questions, and then you will have a few different ways to answer these. And I noticed that we now have the site on the chat window for those of you who are sort of struggling with your browser. So go to the chat window, you can click, and you can get to the site. So we're going to start with something very simple to get you guys used to this particular poll everywhere system. What we're going to ask you is, and I see people have already started answering, which is great. Do you have a behind the meter storage system installed in your home? So many of you, 30% of the US grid is now renewable, right? Some people are using some form of either solar or wind. I'm actually seeing more and more solar in my neighborhood. I live in one of the suburbs of Chicago, and I'm seeing a lot of people do it. We're actually having the conversation now that IRA is passed and there's going to be tax rebates for getting solar panels. The question is, are you going to go one step further and get to a behind the meter storage? I'm seeing that the answer appears to be no, which is consistent with my anecdotal asking a few friends, which is obviously the way we do polling now. But I want to hear from more of you. So I see sort of things changing a little bit. So I want to give it maybe a minute or so to make sure that people have a chance to log in. Again, if you have not logged in yet, it's polev.com/ARGONNE-EVENTS. So Argonne events. You can also text Argonne events to 22333. And once you do that, you have to either type A or B. So this is an answer. If you don't like the answer, meaning if you click by mistake on one of them, there should be a small button on the right side that looks like a garbage can. You can click on it, it'll reset it, and you can go back and sort of change your answer, if you will. So it looks like things aren't changing that much. So, this actually bears out, right? I see a lot of people putting solar, but let's be honest about this. Behind the meter storage installation is expensive, right? And a lot of people can't really afford it. We shall see what happens as this year unfolds and we start hearing more about the IRA implementation and how that all happens. I remain really excited to see if this number changes if we have a meeting, say 2 years from today, where we ask the exact same question. So let's call this particular question done. What we're going to do now is go a little bit deeper now and go into the topic of the conversation today. And by asking you to predict the future. When will non-lithium based batteries, and this can be anything, sodium ion, flow batteries, name what you will, become widespread? What I mean by widespread is tens of gigawatt hour yearly production capacity. Now you might be saying, hey, lead acid is already there. Yes, but we're talking about the next big tranche of applications, the use cases that we've been discussing all morning. The question we're asking you is, what do you think is going to happen? How many years is it going to be? I see an interesting change that is still going on. We want to wait for people to settle down on this. If you're not able to see this question, sometimes what happens is it takes a second, depending upon how fast your network is, for it to move to the next question. And it also takes maybe 5 seconds for it to kind of populate itself on this particular site. So I'm going to give it a few more, maybe a minute or so to make sure that we get the answers we're looking for. Again, the question we're asking is, what do you think the future is going to hold for non-lithium based batteries? Obviously, today, we have, hundreds of gigawatt hours in the United States that is projected. There is a report that came out from Argonne recently, sort of mapping out where the lithium battery production capacity is going to be. And you can see a lot of states, and we'll ask you a question about that in just a second. Here we're asking you what's going to happen to non-lithium based battery chemistries. I see small changes, but I'm actually, I'm kind of optimistic when I see this, right? When I was first, coming up with this question, I thought everybody was going to see more than 10 years, just because, we all talk about this. If there is something exciting today in batteries, it takes 10 years before you can get to large manufacturing capacity. Tens of gigawatt hours is huge. I mean, remember 10 years ago, a 1 gigawatt hour yearly production for a manufacturing plant used to be considered to be a reasonably sized or a big plant. Today, obviously, we're talking about gigafactories and terafactories. But it looks like 50% are thinking that it might happen within the decade, which is remarkable. I am excited to see that some people think it'll be less than 5 years. That's really great. Let's hope that you are correct, and there could be other technologies that can start coming in to relieve the pressure out of lithium. I'm also seeing some people that are more pessimistic, actually significant portion, 40%, saying it's going to be more than 10 years. I guess we'll find out in 10 years which of these is the right answer. So thank you for that. I think what we're going to do now is go a little bit deeper into the next question. This is what we call an open-ended question. So again, for those of you who are not seeing this question yet, just give it a few seconds. You will see it change. What we're asking you is, which battery technology, besides lithium, will become widely commercial by 2035? So this can be, you can say sodium if you want, you can say lead. We want you to keep the answer short, so don't make it such that, think of Hemingway, right? I mean, be succinct, just give us the answer you're thinking of. Ooh, I see sodium's popping up. You can say flow batteries. Yeah, sodium ion works also. Just don't give us a big sentence of what you're thinking, just because that is not the question. There will be other places where you might be able to give us a longer answer. But in general, you want to stay within 5 words for any question we're asking. So I see zinc, I see flow, that's great. Again, we're talking about 2035, so a decade plus. So think about the previous question. For those of you who thought it'd be somewhere between 5 to 10 for 10 plus years, we're asking what would it be? I'm seeing a few more zincs and sodiums coming up. It's kind of interesting to watch these things. I want to give this some time, only because what we notice in poll everywhere is that it sometimes takes maybe 10 to 15 seconds after you type it for it to show up on the screen. High temperature, that's interesting. Obviously, we have various technologies where people have tried to use high temperature. We'll have to see how that pans out. I see iron. One of the things that actually, iron air is a chemistry that many of us are aware of because of work that's been going on. I see lead acid. I see zinc. Zinc has been around for a while, but it suddenly sort of become very important as we look at the different parts of the zinc chemistry. Specific answer for flow batteries there, vanadium redox flow. That's interesting. I think, if you want to kind of go a little bit deeper into flow, you can do that. This may be one of those questions where multiple answers are considered okay. So if you feel like you want to say two things, sodium and say some sort of a flow, then it's perfectly okay to do both because you think that's important. I still see things coming in. Sodium seems to be the one that is sort of the most predominant. But it's, if you were to do this as one of those bar charts, I think you will see that sodium, some sort of a flow battery, and zinc are showing up as the ones that people like quite a bit, which is interesting. I think many of us walking in would have expected something similar. I'm glad to see zinc showing up more and more, right? I mean, sodium is sort of one of the ones that everybody talks about. So I still see things coming in. So let's just give it a minute to make sure that everybody sort of gets the answers in. One thing that happens is that we kind of want to move to the next question when you have a chance. So what I'm going to do is I'm going to ask that we change in 30 seconds to the next one. Ooh, that's interesting. We have a potassium ion battery. That's the first. Very, very difficult chemistry, but I know some companies are pushing on that. So all power. If you can get that going, that'll be great. So let's give it another maybe 20 seconds now, after which we're going to actually jump to the next question. So one thing that came up when we were doing the webinar postings and stuff was, what about not batteries, right? Phase change materials or, come what may, thermal storage. This particular webinar is about batteries. And that's because, as Dave was pointing out, that's what the BIL is going to be. As others like Ben has pointed out, the battery, it doesn't have to be a battery, right? It doesn't have to be a traditional electrochemical storage device. It could be something else. Uranium, that's the one we all want. Obviously, yeah, so this looks like it's getting to a stage where we should be getting to the next question. So I would suggest people should stop typing because, sometimes the system can be a little clunky if you don't sort of stop typing. So I see that we've kind of reached the point where we're seeing all the answers we're looking for. So Bethany, let's move to the next question. Thank you. So now this is what we call as a kind of moving to a sort of a question where we're asking, in 2035, again, we're 10 plus years out, what % of the total US market will be serviced by non-lithium batteries. So remember what we're asking. We've been saying, hey, which chemistry do you think will be useful? When do you think it'll become commercial? Which chemistry do we think will be the most likely? Now we're asking what % of the total US market will be serviced by non-lithium batteries. I am pretty impressed by what I'm seeing here. Let's wait and see how the dust settles on this. But yeah, I was expecting people to say somewhere in the lower end, 10, 20, 20, or something like 20 to 40. We are seeing a lot of that, obviously, but I'm also seeing some optimists here that are saying they'll see this market being larger. Again, this is one of those questions where you can, if you don't like the answer, can delete it and you can start again and mark the one that you want. But again, the question we're asking is 2035. So think 10 plus years out, what % of the total US market will be serviced by non-lithium batteries? And the US market is going to be EVs, right? And hopefully by 2035, we're not talking just light duty, we're talking heavy duty, we're talking some parts of aviation. Maybe we'll be all flying in eVTOLs by the time. There's obviously the whole grid market, whether that is 4 hours of storage or 8 hours of storage, or the long duration 10, 100,000 hours of storage, and the defense industry where there's going to be a reasonable sized market that's important. Which of those do we think is going to be serviced by non-lithium batteries 10 plus years out? It looks like we're reaching a steady state, and it looks interesting. I mean, we are seeing people say that it's somewhere in the middle, 10 to 20, 20 to 40%. And yeah, it's kind of a bell-shaped curve that seems to be peaking around that 20 to 30% range, which is interesting. So it looks like there is some hope for taking these chemistries as a way to sort of broaden out our supply chain so that we're not dependent on one single chemistry or a suite of chemistries that are based on lithium. Again, a prediction of the future. We'll have to see if this pans out. But I'm glad to see that we're getting to the stage where we have other chemistries that can be useful. I still see things moving a little bit, I think, but broadly speaking, we appear to be at a point where at a steady state. So I'm going to suggest that we move to the next question, which we're going to go back to the Hemingway process, right? 5 words or less. What do you think is the biggest impediment to commercializing non-lithium batteries? And the answer can be anything. You can be saying, hey, I know I'm saying it's 20% in the previous slide. I think it can be 100%, but here is the biggest challenge. A couple of examples we gave you. I see people coming in with financing as being a big one, cost, that's a big issue. Interconnection queue, it's obviously a challenge that many people talk about. Yeah, life is a big issue for anything that is a new chemistry. I think all of you, I was kind of reflecting on this, right? It takes decades sometimes to go from something that looks interesting in the lab to something that becomes commercially promising. Lack of performance, lack of financing. This appears to be a theme, right? I mean, how do you get the funds to be able to go after new chemistries? Stability, efficiency, the hysteresis in these systems, oftentimes the Coulombic efficiencies, especially for flow batteries, can be a significant challenge in some cases, not in others, actually, depending upon the application you're looking at. Manufacturing scaling, this is, again, an important part of why this webinar is being held. And how do we solve those challenges, right? Yeah, low TRL challenges really are important, right? Lack of awareness, that's an interesting one. I think these webinars are meant to increase the awareness. So I think this is a conversation that needs to be had. I think this person is talking to everybody sort of looks at lithium batteries and they're so well developed that it's easy to kind of view them as the only answer. And maybe we need to kind of broaden our thinking. When we did the same webinar last year around lithium batteries, the biggest thing that showed up repeatedly was permitting, right? In addition to financing. But I see a very specific answer, which is hydrogen evolution, which is a challenge for many chemistries for sure. Dollars, scaling the supply chain, that's a big challenge also. Lack of research, that is interesting. Certainly I think we've come a long way when it comes to the R&D world. I think DOE has done a fantastic job of sort of supporting many chemistries, but certainly maybe more is needed is what that comment is pointing out. We're going to keep going a little bit now just to make sure we get everybody's input in. Lack long-term experience. Yeah, this is one of the big issues with new chemistries. Or a drop-in replacement. Yeah, that can happen when your chemistry is very different. You're going from a big lithium battery installation to kind of something that looks like a assembled flow battery that can have its own challenges. I'm going to say that we're going to stop this particular question in 30 seconds. So again, for those of you who are still typing, I would suggest that you sort of taper off and stop typing so that we can kind of move to the next one. We are seeing some consistent themes here. The fact that these chemistries may not be mature yet. The fact that there is a financing challenge, the cost of these chemistries, the performance may not be exactly where it needs to be. and kind of really thinking about how are we going to increase the TRL and the MRL of these chemistries is probably very, very important. With that, I'm going to suggest that we end this particular question and move to the next one. The question we are asking here is, in which end-use markets do you think non-lithium batteries can occupy greater than 25% market share at full production? So here's what we're thinking, right? There are many markets. There is transportation, which can be light duty, heavy duty, aviation, rail, there's stationary, which all the things that Ben and Bill spoke about, defense, which Eric kind of touched on, where they were, he's really looking for people to give him some new technologies that can be promising. There's aviation, which we're calling out separately just because of how important it is. We have another category and we have none, meaning that you don't think any of these will ever be useful for non-lithium batteries. And we're asking you, where is the highest probability that you will see these chemistries get more than 25% market share at full production scale, right? That's what we're asking. Not surprising, I'm seeing stationary kind of popping up as the lead winner here. Makes a lot of sense to me that that's the one that everybody will be looking at very carefully. We've already seen this happen with flow batteries, with some of the lead work. And I'm sort of that I think makes sense that people view that as the most logical place where we could see this kind of push further. Seeing transportation show up pretty decently. That's kind of interesting. I think maybe sodium ion could be a great example. We've seen recent reports that sodium could have the energy density of iron phosphate, which kind of allows us to go in a new direction. So I wonder if that's what people are thinking. In the interest of kind of keeping this going, I think this is great. So let's move to the next question. I think we've kind of gotten the answer we're looking for. This is, again, what we call one of these open-ended questions. In 5 words or less, we're asking you, what are some of the early markets the company is targeting as it scales up to larger markets? So let me give you some context here. You might be saying, I really want to be in the grid market, but man, it just is such a cost-sensitive market. Well, it looks like people want to go directly to that. I want to go do something else. I want to go to the defense industry. I really want to work in, say, an airline, some sort of a base somewhere, give them a stationary storage solution, and then move towards utilities. That might be the one that might be giving us harder ones. So I see some answers coming up here. EV fast charge buffer systems, second life. That's interesting. I mean, that's usually spoken about in terms of lithium batteries and what we want to do with them afterwards. And maybe this, again, remember this webinar is specific to non-lithium batteries, so we're asking questions around that. Developing countries, that's interesting. I mean, you would think that you need some sort of a incentive to be able to do that, and you have a new chemistry, it'll be more expensive. So I wonder if that's the, residential has come up, long duration, that's kind of interesting. LDES is coming up a couple of times, so it is interesting. Maybe what we're seeing here is that there are many demonstration projects where you might be able to kind of get that as the early stage, prove the technology, and maybe that allows us to kind of go from there towards the point where we'll be able to get it to the kind of the larger market, if you will, which may be a lot more price sensitive and performance sensitive. So that's an interesting way to think about it. Consumer electronic comes up. That's interesting. I was kind of curious about that, wondering if that's even a possibility, considering energy density is king for consumer electronics. So it's interesting to see that people think that also could be a possibility. Grid backup and stability, EV fast charging, that's come up a couple of times. That's kind of interesting. Certainly as we start to install fast charging stations everywhere, we need more storage technology there. That could be an interesting one. Portable ESS, right? Putting them in a truck, tractor trailer somewhere, and then moving them as we need them. Microgrids, grid management and microgrids is an interesting one. So I'm going to again say, let's give it 30 seconds and we're going to move to the next question after this. We have a few more things we want to cover and we have approximately 7-8 minutes to do that. So in another 25 seconds or so, let's stop this question. We're seeing some consistent themes here. People want to go after some sort of a grid utility scale, try to find out that you can sell into these markets first and then use that as a ability to kind of go into larger markets. We're also seeing some other sort of niche applications like, at this moment, power tools is one of them, I guess, long haul transportation, things where you might be able to start off as you scale up. No, thank you. I think what we're going to do now is shut this question down and go to the next question, where we're going to actually ask you to click on pictures. This is the question that the folks who are not on a browser will not be able to see. What we're asking you is, in non-lithium batteries, you can imagine there's a supply chain. You're starting from some sort of a raw material production. You're going to do mineral processing. You might be ultimately getting to a cell. You might be going to a pack. Then you're supplying to some market. It might be EVs, might be stationary, and then you're going to do recycling in the end, right? In this sort of the stream that you have, where do you think is the biggest challenge for non-lithium batteries? And you can actually click in multiple places. And I'm seeing a lot of things coming up upstream. Actually, the midstream part is where it seems to be the majority of the clicks. And for some of you who are in the browser, you might have to scroll a little bit to see the full screen. So if you're not seeing the bottom, that might be the reason. There actually is stuff on the bottom. If you don't see end-of-life recycling and reuse, it means that you have to scroll down. So again, I'm seeing a lot show up in the midstream, the mineral processing part, and ultimately from that, looking at the sort of the cell manufacturing, it looks like that's where a majority of the people think that is going to be a big challenge. I'm seeing people actually click on certain parts of it. Again, different chemistries are going to be a little different, right? So this is an image we got out of a lithium battery, sort of a supply sheet, but the overall concept is what we're asking you to click on. No, it's interesting. I'm seeing a lot of the midstream, but hey, there is stuff upstream, there is stuff downstream also that we're seeing. I think what we are saying here is that there is a variety of places where there are challenges that people are seeing. A bit of the answer might depend on where you are in the supply chain, and maybe that's the sort of indication that we're getting from this particular plot. So I think we are reaching a point where we have the answer to this question. So I still see a few more dots coming up, but I think overall what we're seeing is significant, I think, concerns in the midstream and the upstream, but certainly one should not forget the downstream part of the supply chain and places where the markets are and some of the recycling part of it. So I think this gives us the input we're really looking for. And again, I want to say thank you to all of you, right? This is extremely valuable input as we start to provide feedback to the federal government in terms of what the community feels is the biggest challenge that we ought to be looking at as we look at the next BIL forward. Now, let's go to the next question, where we're going to go back to this 5 words or less open-ended question that we have. This is specifically for people who are sort of integrators or OEMs. What we're asking you is, you've been maybe playing with the lithium battery chemistry. You've gotten a lot of people giving you data. This is extremely good data, maybe over the last 10 years. Now you're thinking about new chemistries, non-lithium batteries. What do you think is the biggest challenge when you get to new technologies, right? What is it that you're struggling with here? Is it something like calendar life, which the company doesn't have yet? And now you're struggling to say, how am I going to integrate this? Because I just don't know what the life is going to look like. I see some interesting answers coming up. Production capacity, early failures, right? This is a big issue when you have scaling. Reproducibility, yeah. People talk about yields being such a big issue, right? Somebody was telling me that in a big factory today, yields 50% is where you start, right? Which is actually probably pretty good for an early stage company. You got to be at 80%, 90% for it to be a point where you can start to trust that you can get the cost down and get people to believe it. So I see that you need manufacturing test beds. That's kind of interesting. I guess that's a way to get people to accelerate production. Regulatory certification, that is very interesting. There's a couple of times we've heard production capacity. Cycle life, right? Calendar life, cycle life is one of the biggest things that everybody worries about. Yeah, I see volume cell manufacturing, right? If you're only able to provide some small number of cells to a vendor who's really looking for this big sort of ability for you to kind of satisfy them and their needs for the next 3, 5, 10 years, that can be a big challenge. Understanding safety and failure mode, something that can be underdeveloped in these things. Longevity testing, there is a program that is being stood up now with the Office of Electricity and other parts of DOE called the Rapid Operational Validation Initiative that is really aimed at this cycle life validation question that has been coming up. Long cycle life demonstration. So if you've seen the theme a few different times, right? Scaling is a theme, cycle life is a theme. The fact that these things just don't have the performance in the beginning is a theme that we're seeing a lot of. I'll encourage you to kind of take a look at the stuff that DOE is doing, and some of these that might give you ways to leverage what they're doing. But certainly there are other places where I think we as a community need to think deeply about how we are going to influence and make a change. Bankability, question that comes up all the time, right? A friend of mine who actually started a solar company was telling me one of the biggest innovations in solar was not silicon cost. That was happening anyway. It was the fact that they could do solar leasing. The question of bankability really comes up there, right? This is great. I think we're seeing some consistent themes. Just for everybody's awareness, we are recording all of these. We'll have all this information. We're going to synthesize them, make sure that this input gets to the federal government so that they can start to think about what it is that the community feels is the biggest challenge. So rest assured that even though we're sort of not reading every one of them here, we will be looking at all the input that people are giving us. So I'm going to say that we're going to stop this in 20 seconds. So thank you all for your input. We deeply appreciate it. I think in a second now, you should stop typing so that we can start to move on. And again, we have a few more questions we want to cover so that we can get all your input by the time we finish. So with that, I think, Bethany, let's move to the next question. So now what we're going to ask you is this is what is called a rank order question. So we're asking you, what challenge stops you from expanding production domestically? So the way this works is that we're giving you a few options, right? Things like lack of access to finance, permitting delays. You will click on the one you want, and then you'll see an up and down arrow. So you can move it down or you can move it up. Focus on the most important one and move it up all the way. Do the second one. The rest of them, if you don't really have much of an input, you can just leave it as is, but really focus on what you think is the most important. But it helps us a lot if you kind of at least rank the first 4, right? So after that, if you're not worried about 5 and 6, don't worry about it. So the things that we're providing here, lack of access to finance, permitting delays, skilled workforce, something that comes up all the time. If you're looking at a non-lithium battery, do you have access to sort of these suppliers, right? The market size might be limited. Which of these do you think is the biggest challenge that stops you from domestically producing it? Frankly, I think there is going to be a theme here that is going to be similar for lithium batteries and for non-lithium batteries. In this particular question, remember that after you finish doing this, you have to hit submit at the bottom. So if you haven't hit submit, it's not going to show up on the screen that you're seeing. So please make sure you hit submit in the very, very end. That's the only way it'll show. So again, let's take a second to make sure that people are ranking them. It takes a bit to kind of click on those things and get them up, and then make sure you hit submit so that absolutely we can see the answer. We're seeing some themes here. Lack of finance showing up as an important one. We see some movement between things like access to suppliers, skilled workforce, and permitting delays. Permitting actually showed up quite a bit last year when we asked this question. Not that that's going away, we still have a permitting challenge, but maybe we're seeing that because this particular webinar is more focused on non-lithium batteries, we're seeing a lot of people struggling with the financial question here. That might be the reason we're seeing that bubble up. And when you have, when we've seen this happen in other industries, right? When an industry, for example, a particular chemistry takes off, the suppliers all kind of come around it and you form an ecosystem, and that it all has to happen together. We might be seeing those challenges for anything that is a non-lithium battery where things are still in the lower TRL, MRL range. So again, we're seeing small movements happening between the 2nd, 3rd, and the 4th places, but lack of access to finance seems to be kind of staying stable. So I'm going to call it and say, let's move to the next question, which is really an important question. So I'm going to take a second to make sure you all get there. So this is again a 5 words or less question. What is the single most important action the US government can take to incentivize domestic production of non-lithium batteries? Now remember, Dave has pointed this out. They have started doing a lot about lithium batteries, right? They did that in the BIL. The IRA is now out, so that's going to help everybody, lithium, non-lithium, everybody. What is it that they should do for non-lithium batteries? The single most important action. So again, keep it brief. I'm going to give it a second so that people actually give the answer, because it's an extremely important question that we want to get your input on. I see something that is near and dear to my heart: fund non-lithium research. Certainly, I see more and more of the R&D funding. That really is something that obviously people like us think deeply about in the national lab system and the universities. I see financial support, which I guess people are saying is a big challenge that they're facing. Long-term funding, yeah, I mean, again, it takes decades for us to kind of go from where we are from a lab to a market, and sometimes even in the lab, it takes a long time for us to get there. To what China did, that's interesting. I mean, many of you know that industrial policy is something that has been going on in other countries for a long time. We are certainly trying to do that in the US now, maybe in another name, but they're obviously sort of ramping up dramatically in that area. Funding basic and applied research, access to finance. Yeah, I see consistent themes here, right? Support manufacturing, give us more money, make sure you're supporting R&D, because R&D for a long time, it sounds like are the kinds of things that people are really sort of looking at. Pilot scale demonstration, this has come up multiple times, actually, this idea that you have to have some sort of a pilot scale so that we can kind of get to a point where we can try to move these things where it needs to be. So I'm going to give it 30 more seconds. This has actually been very, very interesting to kind of watch these things come up. Probably a way to navigate the many programs. Yeah, there are ways to do this. For those of you who kind of are struggling with which DOE programs are there, I would suggest you go to Fed Connect. There are ways in which they would sort of ensure that they're providing all of that. And these kinds of webinars really help you, right? Because they give you a sense for all the things that may be going on. Tax credits, funding for startups, research funding. We are seeing consistent themes. And like I said, we are recording all of these things, and we will make sure that we give you this input. We take this input and provide it to the federal government in the end of this. Access to national labs, near and dear to people like me. Frankly, you have access to all the labs. If you're confused, connect to your local national lab, wherever you might be. There is Many states have one. If you're on the West Coast, there are a few. If you're in the Midwest, you have a few. Please connect. We will help you get them. Lithium tariffs, right? That's one way to incentivize non-lithium batteries for sure. Fund LPO summits. I'm going to suggest that we stop this question, and I'm going to do only one more question, and then we're going to stop this webinar. This is an extremely important question. That's why I wanted to make sure we do this. Skills. This comes up all the time. So it's not just about a supply chain challenge in the US. We have a skills gap. So the question we're asking is, what is the biggest skills gap for a robust domestic battery industry? This is a rank order question. So again, you will click, you will move the one that you think is the highest challenge up to the top, then the next one and the next one, and then remember to hit submit, because if you don't hit submit, we will not see the answer. This will be the final question we will ask. We actually had a couple more, but I think in the interest of time, this webinar is supposed to end like exactly at this moment. So we're going to actually stop this webinar because of that. So this has been great. We're getting a lot of input. So again, please make sure you rank order. We're asking you, which is the biggest skills gap when it comes to building a robust domestic batteries industry. And again, you have to hit the submit button in the end for you to be able to kind of move this out. What we've seen in the past, and Liebridge actually did a survey, we looked at this very, very carefully. This skills gap is across the spectrum. We were just curious to see if this is a consistent theme that we hear all the time. This is probably the fourth time that somebody's done a polling like this. We've done it a couple of times. NatBat has done a skills report. The Energy Storage Grand Challenge actually looked at this also very, very carefully. And we are seeing some themes that come up in these things. And I think overall, the thing is that we have a supply gap everywhere, right? That's kind of the overall theme. But as we build more of these domestic manufacturing facilities, this idea of process engineers and technicians and plant operators has also become an important challenge that we're seeing, which is, I think, what this particular question is reflecting. I think we are seeing the number reach a steady state. So I'm going to suggest that we actually stop the polling with this. And again, first of all, I want to thank all of you for taking the time to answer these questions. This has been great. You will see a few more questions pop up here, which we will not be going through in the interest of time. Sorry, somebody has to mute, I think. So first of all, I just want to make sure I thank various people who participated today, the plenary speakers. It's been great. The polling questions, like I said, we will provide that input that you've provided, and thank you for taking the time to do that. We'll summarize it, make sure we pull out all the information that has come out, and then we will make sure that gets out to the Department of Energy and other federal agencies so they can start to look at that and see how to implement it. With that, I'm going to hand this back to Dave Howell so that he can finish this meeting. Thank you all, and Dave, you're on.
Hey, thank you, Venkat. Again, great job. We did our own informal poll here at the Department of Energy, and first, your day job is to be a battery R&D innovator and continue to support this space. But if you're looking for a nighttime gig, Jeopardy host may be a good spot for you. You did just absolutely terrific. We really appreciate it. Also want to thank our plenary speakers. Just again, you hit it out of the park. Thanks, Ben and Bill and Eric as well. Really great start. As I mentioned, phase one of our IIJA activity for battery materials and processing really dominated by lithium ion, and the market is significantly dominated by lithium ion currently, and even projected to be dominated in the near future by lithium ion. So we received a significant response in that space, as you could imagine. But we do think that in phase two, as we go forward, that there's certainly room to support non-lithium battery manufacturing deployment. And so that's what these discussions are all about. That's what the polling questions were all about. I mentioned that the IIJA, constrains us to the project size and the cost share, so that's not going away. And it's certainly market uptake in your application and market projections and connections are going to be critical as well. And some of us mentioned DOE supports a lot of research and development in non-lithium ion battery space. So we do see that continuing to happen and even look to expand that R&D activity as well. In the long term, the Manufacturing and Energy Supply Chains Office, we're focused on building out the critical manufacturing supply base across the energy sector industrial base. even after IIJA and the Inflation Reduction Act, including that scale up and first commercialization activity that's so much needed in our space. So hopefully you'll be hearing more and more about plans and visions for MESC in that realm. So, so in closing, I'll just close out here. The federal team looks forward to our continued discussions with this community. And again, great job, Argonne, and the presenters today. So really appreciate it. Back to you, Venkat.
Thank you so much. And I think that ends today's webinar. So thank you all for attending, and stay tuned for more events like this that we'll be planning as part of these efforts, ongoing efforts. Thank you all.